So we're going to look at typical Regents questions that are connected to this. And I made this little kind of chart of things you need to think about. It says all questions on Regents asking students to rewrite exponential equations in terms of different time periods or multiple choice. You're going to work from questions and look for patterns. So I have a little what to look for thing here, and we're going to use it for the first question. So these are all directly from the Regents exam. Stephanie found that the number of white-winged crossbills in an area can be represented by the formula C equals 550 times 1.08 to the t, where t represents the number of years since 2010. Which equation correctly represents the number of white-winged crossbills in terms of the monthly rate of population growth? So the first thing we're going to do, and I'm going to write it up here, is what is my starting time unit? So my starting time unit is years. And they want my ending time unit to show monthly growth. So my ending time unit is months. And to convert between those two, when I go from years to months, I'm expecting my rate to get smaller because less change is going to happen in a month than a year. So the next thing I need to ask is, from my starting equation to my ending equation, did my variable change? And the answer is no. Okay, so even though they want me to go to months, they kept t, which is years. So what this tells me, and I'm going to come back to this last question, I have years to months, which is 112. So that means my 1.08, I don't want all that growth, I want 1/12 of it. Okay? But that would completely change the equation. And we know we can't just throw stuff into an equation, like we have to write something to balance it. Okay? So this is showing that monthly growth. But so I don't change my equation because the variable didn't change. If I have a 1/12 in here, I need to write a 12 on the outside to balance it out. Okay? The 550 really has nothing to do with any of us, but I'm going to write that down now. Okay. Now, they want to reveal the monthly rate of growth. So that means that I need to type this in my calculator so I can see the number that would tell me about the monthly rate of growth. So this is like what we were doing on the other page, just in the middle of an equation. So if I take that in, the 1.08 to the 112, I would get 1.00643, and I see that's this answer. Now notice, they have the same answer without the balancing 12 on the outside. They have this with another 112 here, which would confuse you with this 112, and then 4 is probably not something that you should ever think. So that's the idea of what we're doing. It's tricky because I know last lesson we were like collecting the base and doing all that, but based on what the words tell me, that's how I want to show it. I want to show that monthly rate of growth, which we could find from this. We would get 0.643 growth per month. Okay, let's look at another one. The black bear population for a certain area of the Adirondacks can be modeled by this equation where t is measured in years. Kieran would like to rewrite this model in terms of a 5-year growth rate. So we're going from years to 5-year. That's getting bigger. I'm going to need more growth, so I'm going to use a 5. Looking here, I start with a t, and I end with a t. So my variable did not change, so no variable change, which means I need a balancing number. If I use a 5 to start out with, I'm going to need a 1/5. So what this looks like, I have my 1.026. I need more growth, so I'm raising it to the 5th. And then I need a 1/5 out here to balance it. And that start number is just always going to go in front. Now to reveal the 5-year growth rate, or in terms of a 5-year growth rate, I need to type this in to see what number is going to show me my 5-year growth rate. If I type that in, that is going to give me this number. And I notice I want the t over 5, right, the 1/5 t, so it's going to be choice 3. So looking at the next one, the number of people who have read an article grows exponentially throughout the day and can be modeled by this function, where t is the number of minutes. So we are starting with minutes. Which equation represents the number of people who have read the article in terms of the growth rate per second? So minutes to seconds. Seconds are faster, so I'm going to have less growth in a second. So I need a 1/60th. Once again, my variable did not change, right? So no variable change, which means I am going to need a balancing number to keep my equation equivalent, which is a 60. So I have the 2 in the front, the 1.0098. I don't want even that tiny bit of growth. I want less. I want what's happening each second. Let me put the 60t out here. Now, when I take that in, that's going to give me an even smaller number, which is this number, right? And that shows the 60 in the front. So just stepping back a little bit, we're doing seconds, so there's less change more often. And that should make sense, right? Seconds happen more often, so I'm multiplying the t by 60, but there's less, like, smaller pieces of change, which is why I need the 1/60 with the base. In the same way here, in 5 years, there's more change than in 1 year. And this t/5 shows less often. And that's going to become important in the next section we do. But we have 2 more questions at the top of the next page that go along with this, so we're going to do those as well. So according to the USGS, an agency within the Department of Interior of the United States, the frog population in the U.S. is decreasing at the rate of 3.79% per year. A student created a model with this equation to estimate the population of the pond after T years. The student then created a model that would predict the population after D decades. So we're going from years to decades. And hopefully we all know a decade is 10 years. So that's longer, so I'm expecting more decrease in this case. More of whatever it is, this one happens to be decreasing. But that doesn't really change the problem here. So we do notice for the first time, we started out with a T, and now we're using a D, which means there is a variable change. So the variable change kind of took care of that balancing number. Okay, so we just changed to a new time period, so I don't need to use a 1/10, because I do actually want to know what's happening each decade for the D. So when I do this, I get my 0.9, read under my pen here, 0.962 to the 10th. And now instead we're using a D, so this does represent the correct number. Start number will still be the same. So when I take this in, that is going to give me the 0.679 to the D. So the next problem, we have the total revenue for home style. T is measured in years, and we want to know which one of these we could use for a monthly person increase. So I know I didn't read the whole thing. T is measured in years. So we have years to months, right, which is getting smaller. So this is 1/12 of that growth. And again, we see we started with T and we're changing over to M. So there is a variable change. So we don't need a balancing number because that's taken care of and changing the variables months. So I start out with my equation. I want 1/12 of that growth per month. I need to change over to months. And if I take this in, I am going to get 1.0427 as those things. And as I'm looking at this, I believe I typed up this equation, and I think I need 2 zeros in there. So if you type this in, that makes a whole lot more sense for what I should be getting, so this should be 1.00427 there for that one.